In this video we're going to continue with the topic of trigonometry C, and we're specifically going to study minimum and maximum values of wave functions. So if we express a function of the form p cos x plus q times sine of x as a single trigonometric function, and that could be any of the ones on screen just now, we can then find the maximum and minimum values of the function and the corresponding angles at which these values occur. And these are basically graph transformations based on the graphs of cos x and sine x. And because of that, it's really useful to remember the minimum and maximum values of f of x equals sine x and f of x equals cos x. So we'll look at those first. If we start with f of x equals sine x, we can see that there's a maximum value at the point 90, 1, and a minimum value at 270, negative 1. If we look at the graph of f of x equals cos x, we have maximum values at 0, 1, and 360, 1. And we have a minimum value at 180, negative 1. Now we could also look at these graphs in radians as well. So for sine x, the equivalent maximum value for radians is pi over 2, 1, and the minimum value 3 pi over 2, negative 1. And for f of x equals cos x, 0, 1 and 2 pi 1 for the maximum values, and for the minimum value we've got pi, negative 1. So let's have a look at an example. We want to write cos x plus 4 sin x in the form k cos of x minus alpha, where k is greater than 0 and alpha lies between 0 and 2 pi, and we want to state the minimum and maximum values and the values of x at which they occur. So our solution then, k cos of x minus alpha will be equal to k times cos x cos alpha plus sin x sin alpha. So that's our expansion for cos of x minus alpha. Multiplying throughout by k, we get k cos x cos alpha plus k sin x sin alpha. And we can now equate coefficients to obtain our simultaneous equations. So looking at the coefficient of cos x first, we've got k cos of alpha is equal to 1. And looking at our coefficient of sin x, that means that k sin of alpha is equal to 4. And now we can solve for k. We can square each of the equations, remember, and then if we add those together, we will get k squared times sin squared alpha plus k squared times cos squared alpha is equal to 16 plus 1. So remember, we've squared both of those equations and then added them. Now on the left hand side we can take out a common factor of k squared and we can evaluate the sum on the right hand side. So that gives us k squared times sin squared alpha plus cos squared alpha equal to 17. And remember, sin squared alpha plus cos squared alpha is equal to 1. So that we can conclude that k squared is equal to 17 and therefore k is equal to root 17. Now we need to solve for alpha. So k sin of alpha over k cos of alpha is equal to 4 over 1. And remember, our k's there will simplify to 1. And remember, sin alpha over cos alpha is equal to tan alpha. So tan alpha is equal to 4. And we need to know which quadrant our angle is going to lie in. So we can use our cast diagram. For our equation involving sine, that's positive. So we have the first and second quadrants there. And for our equation involving cos, it's also positive. So we have the first and fourth quadrants. So that means our angle alpha will come from the first quadrant. So inverse tan of 4 is equal to 1.33, and you should remember that you're working in radians, so your calculator needs to be in radians. So alpha is equal to 1.33. And we're now in a position where we can express cos x plus 4 sin x in the form k times cos of x minus alpha. So that's root 17 cos of x minus 1.33. So we have now written that in the given form. And now we're required to state the minimum and maximum values and the values of x at which they occur. So if we firstly look at the graph of cos x, okay, we can pick out our minimum and maximum values from there. Okay, so we've got the point 0, 1 for a maximum, pi negative 1 for a minimum, and another maximum at 2 pi 1 as well. If we now look at the graph of cos of x minus 1.33, so remember we're adding 1.33 to all of our x coordinates, so that will give us 1.33, 1, 4.47, negative 1, and 7.61, 1. And we can then multiply all of our y ordinates by root 17 to get our maximum and minimum values for the function root 17 cos of x minus 1.33. And we'll get 1.33 root 17, 4.47 negative root 17, and 7.61 root 17. Now, we want to know the maximum and minimum values between 0 and 2 pi, and we can see that this one here at the bottom will be out with that range. So you can see there, if I draw that graph, you can see that the 2 points that I've chosen here, I've worked out that those are the maximum and minimum values, and you can see that from the graph as well. So we've got a maximum value of root 17 when x is equal to 1.33, and we have a minimum value of negative root 17 when x is equal to 4.47. So it would be a good idea at the moment to pause the video before the screen goes blank, copy this example down in your notes, and then try some of the exercise on minimum and maximum values.